So one thing I've wanted to do for quite some time now is to build myself a little garden that's automated with a Raspberry Pi. I finally got around to it, so I'm going to show you exactly how I did that. You can go to my GitHub to get all of the code. You shouldn't have to write any code if you don't want to. You might have to alter a configuration file, but that should be about it. I'm going to show you how to set up some soil moisture sensors so that we can keep track of whether the soil is wet or dry. I'm going to show you how to set up some pumps like I've got down in here that will water the plants when they need it, when the soil's dry. I'll also show you how to set up light to give your plants whatever kind of light they need throughout the day. This is the soil sensor that we're going to be using. It's just says capacitive soil moisture sensor version 1.2. You can find schematics for this online. I haven't really been able to find a definitive manufacturer, but they do work pretty well. I've had a lot of luck with them, so let's get started. All right, let's talk about parts real quick. So we've got obviously the Raspberry Pi. I've got a Zero here. This is great. I actually like to develop on a Pi 4 or Pi 5 if you've got something like that available. But if not, this works just fine. Like I said, you're going to be able to download all the code, so you can just load it straight onto here. The other thing you're going to want are these header pins. I do have a video showing how to set up these Raspberry Pis to prepare them, their header pins, as well as the micro SD card that you're going to need to go into the Pi. So you can check that out if you need to know how to set these up. But if you're watching this video, I'm guessing you may already kind of be a Pi veteran. You are going to need this soil sensor, like I showed you in the intro. We'll need pumps. These are the ones I bought on Amazon. They've got the tiny little wires on them that are kind of obnoxious, but they're okay. They work really well, and you'll want some line to go with them. These actually come with the ones that I bought on Amazon, and I'll post the link for that. Relays. You're going to want relays to run any pumps that you have, and you're also, if you're going to use a light, want a relay to run your light. I didn't bring this one down. I should have for the parts list, but you are going to want a grow light there. Breadboards. You'll probably want a couple of breadboards. In actually, one of them I only use for the rail, this top part here. So if you want, you can kind of like break those and they separate away like that. DuPont cables. These are what you're going to use for connecting all of your components. And then as far as tools go, we just got some pliers, some wire cutters, soldering iron with some solder and flux. I'll talk about these guys later, helping hands. These are great for soldering those tiny wires. I'm showing this only because I do recommend maybe on these cables putting some of this silicone sealant if you have any parts that might be exposed to water. And then it's always good to have electrical tape to cover up any exposed parts. We're also going to need to set up this ADS 7830. This is actually what it looks like here as an IC. I'm using something that fits onto a breadboard just a little bit better. You can see it's got the IC right there in the center, actually, but it has all the resistors and everything already built into it. I was going to just do this project with only this ADS. I had it laying around from a long time ago, but when I went to go and try to buy more of them, I couldn't really find this exact model. So I have adapted the code also to be able to run on the ADS 1115, which I'm showing right here. You'll just have to make a small change in the configuration file, and I will show you that later. Another thing to note is that this actually has 8 channels on it. The 1115 has 4, so you can do more than one plant, which I, in fact, decided to do. I'm going to do 3. But really, the functionality of this whole project is going to revolve around the soil sensor, so let's get that set up. So we've got the Pi 4 here. I've got my ADS 7830 down here on the breadboard, and then the capacitive soil sensor over here. You can see on the Pi, we have this orange, purple, and green wire hooked up here, as well as the black hooked up to the ground. So this is your 3.3 volt pin. These are your two I2C pins, and then the one coming forward here is your ground pin. Coming over to the ADC, we have again our green water wire running here into the SCL and purple into the SDA. You can see the ground is running here, and then again over to our ground pin on the ADS. Our orange here, power running over, and then again into the ADS. And then our black, red, and yellow wires are all going to be moving over to the sensor here. The red being our power, black being ground, and then our yellow wire running into channel 0 here we can see on the ADS. One big part of getting these sensors set up that's going to be necessary is to do a calibration. We don't really know exactly what the values are going to look like that the sensor returns, so we just need to do some experimentation to figure out exactly what those values look like. So I've got a few different vessels here to test, and this is going to be all about finding those values that we need to put into our code to determine if the soil is wet or not. So you can see I've got the Pi all hooked up back here with the analog to digital converter. I have on the desk here, this will be our dry conditions. I have some dry soil. I have some just moist soil, and then I have some water to just kind of see what we get when we're just purely moist. Although this technically isn't measuring water, this is measuring the conductivity through the water, but this is tap water. It should get our kind of our max reading. So here we go. I'm going to bring up the code, start running. And so it looks like on the table here, we've got a value of 217 is what we're getting. So let's bring it over into our dry soil. And that didn't change things much. It looks like we're getting 214. I'm going to shove it in a little further just to see if maybe, okay, 207. So we're pretty reliably still above 200 in the dry soil here. Let's come over to our moist soil. Get it down in there. Try not to get the electronics because I know those won't like it. Okay, now we're getting a little different reading here. We're getting close to 130, and this is pretty saturated soil. I did put a bunch of water in here, so let's see how that compares to just our regular water. Oh, well, I'm going to get dirt in my water. That's okay. Let's see. Not dipping electronics in. And we are at 110, 111. So that kind of seems to be about as low as we're going to go. Let's see if I can get it in here without touching the electronics. Now we're down to 103. So kind of our max, well, I guess min. The wettest it's going to be is probably right around 100. And then as we get up around 200, we know we're definitely really dry. All right, I've got our plants all set up here. I've got the Pi 0 pulled away and out by itself. I do have SSH running across the room, but you can see here I've got channel 2 pulled out and the light's on right now. This is kind of a middle state. The light will be replaced by, of course, the relay for actually watering the plant. And you know, if we put this back in here, should see the light go away. Yep, there it goes. And yeah, like I said, over here, we've got it monitoring all three sensors. Well, I was waiting on things to come in the mail, like the pumps and the lights. Might have gone a little overboard and made a little display shelf for my plants. And now, let's talk about the relays we're going to use to run the pumps. So, if you've never used a relay before, they can look a little intimidating, but really they're pretty simple. You've got two sides to them. You've got this one that you're going to be controlling with the pi, and this is the side that's going to turn it on and off. This is the side that is actually going to turn on and off. And for this project, we're going to want to use the normally open side, meaning that the circuit will not be complete by default, and this COM port here. On this side, we'll use all three. We'll power it with 5 volts here on the DC plus, or it may say VCC on yours. The DC minus here will be our ground pin. And then the this is what's going to connect to our Raspberry Pi pin in order to switch the relay on and off. To clarify, let's look at our board. You can see here I've got a purple and a white wire that are going to end up clear back here running into this relay, and that purple and white are going to be power and ground respectively. I also have that red-orange one there next to them, and that is going to run over here to the Raspberry Pi itself. I then have on this end of it both of my ground wires. Actually, this ground wire, the white one coming from the COM port, is running here to my pump. And then that gray one is going to run over to this power source that's coming from the wall. Remember, you need to power with a different power source than your Pi. The pump will burn out your Pi if you try and power it directly through the Pi pins. Now, let's hook some pumps up to these relays. So to hook up the pumps is pretty simple. They come with a pretty short wire, but that's really okay as long as you can pin the wire up over the top of something. You can see I've kind of got that going on here. These are actually clipped on the back. You can't really see, but so the pump has these two teeny tiny little wires that you're going to have to deal with getting power to. I'll show you how to do that in just a minute. Here is the pump kind of wired up. It came with tubing that fit really well. I think they gave me, I don't know, probably 2 feet of tube for each pump, which is a good amount for getting up to where it needs to go. My shelf, like I say, is right up here, and it does manage to wrap around the shelf from the water reservoir up to the plants. But like I say, you will need to get that red and black wire secured to something else. And then I here finalize that by just soldering to some DuPont wires to make it nice and easy to go into the relay and into the board. Quick public service announcement. You're going to see me using USB power plugged into a surge protector that's made specifically to deliver that USB power. Under no circumstances should you be cutting any wires that will go into main power. If it plugs directly into the wall, you should not cut that wire. It's unsafe and you can hurt yourself. Power from the pumps really needs to come independently. I can't stress that enough. Do not try and power your pumps with the Raspberry Pi. You will fry your Pi trying to do that, and that's no good. Again, for the power, I actually just cut a USB cable, soldered in, again, some DuPont cables, reinforced it with tape just to make sure we're not touching any electric parts. But yeah, like I say, USB 5 volts give plenty of power to these pumps. Real easy way to do it, but go to your board here, not to your Pi. That's what you need to do for your pumps. That being said, I have my USB plug here that runs over, oop, my light just turned off, up here, just come back here, along the back and to my board with the positive side going. That's the positive side is the red wire there, and the negative side, obviously, the black wire. You can also use batteries, but I don't like to use batteries because then you have to replace batteries, and who wants to do that? Just a side note, these pumps do have really, really tiny leads on them, so let's see if I can show you here. They've got just really, really small leads, so it's a good idea to have something to hold them still as you're soldering. I got these helping hands on Amazon. I think they're like 30 bucks, 40 bucks maybe. But yeah, good idea to have something like this. Like and subscribe. Now let's touch on the light subject. But I have my light up here. Down here, I just have the cord, the power cord, and you can see I've just got the two wires running from the positive side. I soldered back together the ground side and just split that positive side so that I can run one end each into the relay. And then obviously we control the light relay from the board the same way we do any of the pump relays. So I bought this light on Amazon, and I wasn't thinking too hard about it when I bought it, but it did end up having this little module on it to control, to put a timer on the light and control brightness and all that stuff. That's really cool and all, but it kind of got in the way of just needing to turn the light on and off each time the relay flipped, because it found if this thing lost power, it would default back to a state of off. So when I first wired it up, it wasn't working right, because each time the light would turn off with the relay, it would then remain in an off state even when the relay turned back on. So just a caution there. All I had to do was clip it off. You can see there's just a red and black on this side. There happens to be a yellow on this side. You can just ignore that data wire if you get a one like this. Just hook to the red and the black. Just cut this little piece out of there, and then you've got something that you can do later if you want. You can have some fun with this thing. I found this cool little chip inside there. I'm going to play around with that later. Don't forget, I'll include all of the parts you need for 3D printing on my GitHub as well in the repository. We've got this wonderful water tank, these clips to hold your hose up. We've got the kind of the board holder here. Yeah, all that good stuff will be there too. All right, let's talk about how to get the code on the Pi and how to get it running. This is actually really easy. We're going to use a tool called Git, G-I-T. All we have to do is type in some code into the command line, and it's going to bring everything to you. So just make sure your Pi has internet access set up. If it doesn't, go check out that video I was talking about earlier where it'll show you how to set up the Raspberry Pi. But yeah, let's get started. Let's see how to set this thing up and how to configure it. The first thing we need to do is make sure Git is installed on our Raspberry Pi. So we're just going to type sudo apt-get install Git. And it should read those packages. It'll note for me that Git is already installed and the newest version. Do note that if you're installing Git for the first time, it will ask you if you want to install it, yes or no. You'll need to put in a capital Y, not a lowercase y, before you hit enter. It will not accept a lowercase y as yes. It needs to be uppercase. That being said, once we have Git installed, we can reboot the device. You can do that with the command sudo reboot. That really is optional. You should be able to use Git without rebooting. So I'm going to go ahead and do that. We're going to type git clone, and then we're going to put in the address of my code, https://github.com/David Miles 1925, 1925, and it is called plant care assistant.get. We'll push enter. And it's going to take a minute to load. Great. Now we've got the repo. We'll have to go into the directory. And we can just push the P and then push tab. Unless you've got some other directory that starts with a P, then you'll have to type out plant or something like that. Push enter. So before we run the program, we're going to need to set up the configuration file. This isn't coding. All we need to do is open a file and change a few values potentially. So I'm going to I'm going to start in Plant Care Assistant directory. You can see that here. On your Pi 0, if that's what you're using, you may not have a mouse. I'm just using SSH on my Windows computer right now. But anyway, we're going to be in this Plant Care directory. And we're going to do sudo nano. That's going to tell it to open a text editor. And then we want config.py. We'll push enter. So once we're in the config file, we're going to look at these variables right away here at the top. The very first thing you absolutely have to change in order for your code to work is the Pi username. This just needs to be whatever username you set up with your Pi, whatever you use to log in with. This is what needs to go here in between these quotes, is that username. Number of analog inputs. So this is going to be the number of plants that you have, basically. So it knows how many pumps to cycle through. If you only did one plant, you need to change this to 1. I have 3 plants, so I'm leaving it as 3. Duration between checks. This is just how often it's going to check your soil moisture and put it in the log. 1800 seconds is half an hour, so that's what I've got it set at. Just every 30 minutes it's going to check. And then after 6 checks, that's what this variable is, dry count before watering. After 6 checks of returning dry, basically I'm saying after 3 hours of being totally dry, it's going to water the plant. And then this one here, water if dry, this is just true or false. You can turn this to false if for some reason your pumps aren't working or something, or you're doing maintenance and you don't want the pumps to activate for some reason. Moving down, this relay pin you can ignore unless you've changed the pin for some reason while you're putting together the project. The start time array. So these are all the times that your light is going to turn on throughout the day. And I should probably explain why this is happening. Some plants, like the ones I have, just really don't like a lot of light and can get scorched if their leaves are exposed to direct sunlight for too long. So I'm giving them 900 seconds, that's 15 minutes, of sun every 2 hours. So at 8 a.m., the light turns on for 900 seconds, turns back off, and then that happens again at 10, 12, 2, 4, and 6. So and then I think you can kind of ignore the rest of these. These capacitive moisture sensor values, if you did your own calibration and you're not just trusting me on these values, then I think you should probably need to update them. I would recommend doing your own calibration. Don't just take my word for that your sensor is going to put out these same values. This is a very important one too, pump time on. So this is how many seconds you're going to turn your pump on for. I've found that with the length of my hose, the pumps that I've used put out about half an ounce of water in a second. So by this rhythm, my plants get, if they're dry, they get a half ounce of water. If they're still dry 3 hours later, they'll get a half ounce of water again, so on and so forth. And this just prevents overwatering of the plants. Down here, if you're going to be using the ADS 1115, then you are going to want to actually take these little asterisks, or not asterisks, whatever these are, hashes, out and put in new hashes here.
Okay, and then you'll save your config file like that. And these are just the values that you're using to talk to your particular unit. If it's the ADS 7830, these top values are the ones you need to use. If it's the 1115, these bottom values are the ones you need to use. If it's some other sensor, you can follow this same pattern here. You'll just need to find out what these hexadecimal values are. And then this all down here, you don't really need to worry about. If you want to turn off logging for some reason, you can. And then here's just a reference of how many seconds make up an hour, a day, and a week. That can be useful for some of the variables up top here. Once that's all finished, I'm actually going to put back my, since I'm using the 7830, again, just to reiterate, I need to be using these top variables. And we will hit Control O or Control S, either way, to save. It'll tell us that it wrote out lines, and then we will push Control X to exit. One thing that is going to be absolutely critical for you to do is to turn on ARM I2C. And we'll do that through the Raspberry Pi configuration utility. So to get into that, we'll type sudo raspi-config and push enter. And that will open up this GUI. We will come down to advanced, we want interface options here, number 3. And we are just going to come to I2C, enable, disable automatic loading of I2C. Yes, we would like it to be enabled. And it will go ahead and enable that for us, and that is done. If you don't do this part, your analog to digital converter won't work properly. You'll get an I/O error of some kind. If you are getting that error, if you see an I/O error, check your connections on your pins and also check that you have this enabled. If you don't, like I say, it won't work. The other thing we definitely need to do before we're going to be able to use the analog to digital converter correctly is to make sure smbus is installed. So we're going to type sudo apt-get install python 3-smbus, and we'll push enter. And it will do the install. For me, it should already be installed and up to date. Yep. But for you, it may want you to go ahead and install it. Okay, at last it is time to run the code. Make sure that you're in your plant care assistant directory. And then we are going to type sudo python plant.py. Fantastic. We've got the code running. I believe you should be able to see in my other window that we have the number 3 sensor out of the soil. And so on screen, you can see that it's reading as dry. This is going to be for testing. We want to make sure the pump is working. And of course, we'll go through and do this with each individual pump, but I'm not going to put you through that. We'll just do number 3 here. So let's close the program by pushing Control-C. And then I am going to open the config file. Oh my gosh, I just tried to do Python config. That's not going to work. Sudo nano config.py. Don't do Python. I mean, it's not going to hurt anything, but that won't open it for sure. Let's change the duration between checks to be just 2 seconds. So we'll get about 12 seconds between each time the pump runs. Yeah, 2 seconds. I can't type today. And we'll save that and exit. And then I'm going to run our program again. And let's go take a look at what's happening over at our garden. All right. That pump just ran. Let's see it go one more time just for the heck of it. Great, and we will push Control-C to terminate the program. All right, so we know our sensors, our pump are working. I've tested the light. We are good to go. So once you've got your code working, you've gotten a chance to play around with it a little bit, we may want to take a look at the logs. And the reason for this is obviously this system is designed to be automated and we can be away from it for long periods of time, but we may want to look and just see how it's doing, see how it's been doing, how frequently it's watered, all that kind of thing. So what we can do is navigate to our logs directory. So we'll start by going into our plant care directory, just like we have before. And then we'll go one deeper to logs. Now, just note that this directory will probably not exist if you haven't actually run your code yet. So don't go looking for it and be confused if it's not there if you haven't run your code. The code creates this when it creates logs for the first time. Now that we're in the directory, we can push ls and enter, and that will show us a list of the log files that we have. The moisture log is always going to be notated by a date. So 04/19/24, that's April 19th, 2024. That's going to be our moisture log for today. And then the light log is just a long running log. It's not going to create more and more and more light logs day after day, just because it is not a task that it does very often. The checks for the moisture, though, can occur pretty frequently, depending on how you've set up your configuration. So it does create a new file each day. That being said, we're going to type sudo nano. Again, that's to open a text editor. And then we're going to start with our moisture log. So I'm just going to type a 0 and tab, and that will bring up our moisture log here. Now, I've only been testing for a short while as I'm making the video, so you'll see I don't have a lot logged here. But I'll come to this bottom one where it did have a chance to run a couple of cycles. You'll see that it's logged here with the settings, it's timestamped. So this bottom one started at 5:58 p.m. and was set up to where it will make the check every half hour. It shows you the calibration values that were used, and then it records every half hour or every roughly half hour. It uses a sleep function, so it's not 100% accurate. But it will record about every half hour the values of each sensor here. If it does water, that will show up in here in the logs as well. It hasn't done that yet since I've installed this version of the repo. But just know that that will show up in this log as well. The other log we can look at is the light log. And again, it's just kind of the same idea. You'll see here that it just shows as the light turns on, it will log that, and as the light turns off, it will log that again. Each time the program starts, it's going to give you the settings under which it's running. It's going to tell you the pin, the times that it's going to turn on, and how long that will remain on. I should note, I don't think I said it in the configuration file, that you do not have to match the number of times in here. You can bring it down to just one time. Could just be 8 o'clock. You can put 50 times in here if you want, just as long as it matches the duration here. Obviously, if you put in 24 hours down here and then make it turn on a bunch of times up here, weird things are going to happen. So I wouldn't recommend doing that. But you aren't constrained to the setting it up exactly this way. Anyway, we can hit Control X to get out of there. And that is the logs.
So here it is in kind of its finished state. Still need to print a better box for it, but we've got the water reservoir down here with all the pumps and the wires running up here to our unit, our board here with the Pi and the ADS. Oop, there goes our pump. Pumping water. Right now I'm just testing. I've got number 2 out here. It's out of the soil, so it's reading as dry. You can see we've got our red indicator here, and here in a minute we'll see the pump turn on again, actually. And there it is. Yeah, and I don't think I mentioned, I do have the light on a timer. These ones aren't big on sunlight, so I only have the timer going on every every 2 hours for about 15 minutes during the day, just to give them a little dose of their chlorophyll. Anyway, there it is. That's the setup. So just a note on if you are going to try and use the ADS 1115, it works. It definitely works, but the resolution on it is not great. And I'll show you what I mean by that. Hang on. So excuse the poor connection that I'm having right now, but you can see our total range is like 5 between 127 and 133. This would be fine for a crude measurement of just wet versus dry. You know, you could probably set the limit at maybe like 128-ish, 128, 129 to alert you when you need to water. But this probably might not be the best one to use. If you can find the ADS 7830, it's probably a better choice. And the reason why is somewhat technical. To put it in kind of layman's terms, basically the 7830 over here on the right just really puts out orders of magnitude better resolution than the ADS 1115 does. So definitely the one to choose if you can find it. Remember, there's a link in the description. It's going to get you to the code. It's also going to give you a little bit of a walkthrough. So check those out down there. Thanks for watching.